First, okay. So, hello aspirants. So, what we are going to do in this small video is to study about nuclear fusion. Why this topic is very important for prelims this year? It is because there are many news items that had come with respect to nuclear fusion. So, there was recently a claim made by US that one of its nuclear facility was able to produce more output than the input given to start or run these type of reactors. Previously China had also built a nuclear fusion reactor. So, they call it as artificial sun. Why they are calling it as artificial sun? Because they are utilizing that process which sun utilizes to generate power. And even UK. So, UK also has built a fusion reactor. So, they had also started and experimented with this fusion reactor. But the biggest challenge with respect to the Chinese reactor or the UK reactor was that the fusion was not being able to sustain for long period of time, and that the output of these reactors was much less than compared to the input energy given. So, let us just try to understand what is this fusion in this context, and fusion is referred to as the future of energy. So, if we can tap the energy source that is being utilized inside the sun, then all our energy requirements could be met. Not only it could be met, so all the issues related to like production of energy from carbon that leads to greenhouse gases and that leads to climate change, or if you go for nuclear fission, so we see the issue of radioactive waste, or if you go for let us say solar requires large land. So, all these issues can be resolved if we are able to tap this source of energy, that is nuclear fusion. So, what does this two term mean here, nuclear fusion? So, nuclear means it comes from the word nucleus. Here when we are talking about nucleus, we are talking about nucleus of an atom. So, we are trying to harness energy from atom. We are trying to harness energy by fusing some of the nucleuses. Now, which of the nucleus we can fuse, or what is happening inside sun? So, let us just try to understand what is happening inside the sun, and if you understand that, then we can understand that how we can build a reactor on earth utilizing that concept. So, in sun what is happening? In sun, the source of energy inside sun is nuclear fusion. So, this we know, this is a general accepted fact, but how fusion occurs or what fuses to form what? So, in sun, hydrogen fuses to form helium. So, if we have to understand in this in a simple manner, so four hydrogen atoms they fuse inside the sun or in the core of the sun to form helium. So, if you look at hydrogen atom, hydrogen is the simplest atom in this universe. It is containing just one proton in its nucleus and one electron is revolving around this nucleus. So, how do we go about fusion of hydrogen inside sun? So, let us just try to understand this. So, this is the nucleus of hydrogen and one electron is revolving. There is another hydrogen and we want to fuse it. So, let us say these are four hydrogen atoms which we want to fuse, and we want to get helium. So, if you look at atomic weight of helium is 4 and atomic weight of hydrogen is 1. Helium is the second element in our periodic table. So, after hydrogen we have helium as the next element. So, we have to fuse 4 hydrogen atoms to get helium. But how can we do this fusion, or what are the challenges with respect to this type of fusion? So, when you are talking about fusion is a process in which we are fusing lighter atoms to form a heavier atom. So, here we are trying to fuse lighter atoms to form a heavier atom. But when we try to bring these hydrogen atoms closer together, so what will happen? So, these electrons they will try to repel each other, because we know that same charge particles or similar charge particles, they repel each other. So, if when you try to bring the hydrogen atoms closer to each other, they will repel each other. So, how will the fusion occur then? So what we do in that scenario, that we heat hydrogen to such an extent that these electrons are ripped off. So let us say these electrons by heating you have got rid of. So you have got rid of these electrons. You have got rid of these electrons. And now when we try to fuse, so again this problem arises that there will be electromagnetic repulsion between similarly charged nucleuses. So in the nucleus you have one proton, here one proton, here one proton, here one proton. If you try to bring them together, they will repel each other. So how does fusion occur in the sun? So fusion occurs in the sun because of very, very high temperature inside sun. So the temperature inside sun reaches in million degrees Fahrenheit. So the temperature could be reaching to 27 million degrees Fahrenheit. What happens at this temperature? Two things. First of all, the electrons, they are ripped off, and now these electromagnetic repulsion, the natural electromagnetic repulsion between protons and protons, it can be overcome. So then fusion occurs. So only under this state is called as the plasma state. So for fusion to occur, we need this state. This state is superheated state, superheated matter. So in superheated matter only fusion can occur. So we know that there are three states of matter. This we know it from our schools and colleges that we have studied. So plasma is known as the fourth state of matter. So what is this state of matter? In this state we are heating some gases so that it becomes ionized. Ionized means it loses its electrons, and now because of the high heat they are ready to fuse. So inside sun, because of this plasma, there is fusion of protons. There is fusion of protons to get helium. But the question still remains that how does fusion of, let us say, 4 protons is releasing so vast amounts of energy. So here we need to understand the concept of mass loss. If you look at weight of 4 hydrogen atom, it will come around 4.030 AMU, and if you look at weight of 1 helium atom, it is around 4.002 AMU. So what is happening? What is happening when 4 hydrogen or these 4 protons are fusing together? So you can see here there is loss of mass. There is loss of mass when 4 hydrogen is fusing to form helium. This loss of mass is actually converted into energy. It is converted into energy by this famous equation which was given by Einstein, where c is equal to speed of light. So if we go for calculation of this, then this number is quite a big number. Even when we fuse 4 hydrogen atom into a helium atom, if you go for this calculation, this number signifies that we can light a 60-watt bulb for more than 100 years. A 60-watt bulb for more than 100 years. So can you imagine the power or efficiency of this fusion reaction? That is why it is called as future of energy, and that is what we want to harness even on earth. But what is happening inside sun, that these fusion that is happening inside sun is uncontrolled. But if we want to harness this energy on earth, we need to control this fusion. So in order to control this fusion, we need to build reactors, and let us see one of the design of such fusion reactors on earth. So the most famous design is called as the tokamak design. So what we are seeing next is that how do we build fusion reactors. Fusion reactors. So the fusion reactor the nuclear fusion reactor, you will often hear this word tokamak. Now, this tokamak is a Russian word for donut. Donut is like something like an Indian version would be your vada. So, in this the design looks like tokamak. So, it was first designed by a Russian scientist Andrei Sakharov. So, he designed it. So, after his name we call these fusion reactors as tokamak. So, what is the basic design of this tokamak? So, the basic design, the basic idea or the principle here is that we need to produce plasma. We need to produce plasma and we need to control the flow of this plasma. But how do we control the flow of this plasma? Inside plasma only fusion can happen. So, when we produce this plasma state, then fusion can happen. And how do we control this plasma then? To control the plasma, we have some very powerful magnets. So, these powerful magnets, they control the flow of the charged particles. What is plasma? Plasma is charged particles. So, these charged particles can be controlled by magnets. So, we have built super magnets, and these super magnets are used to confine the plasma. So, that is why it is also known as magnetic confinement design also. We will just see a basic outlay of this. So, it is a tokamak design or a donut. Donut means donut, or the Indian version would be your vada or medu vada. So, the donut, it is a tubular type of structure, and inside this we generate plasma, and the plasma will keep flowing, and the plasma will flow. So, let us say this is the plasma that we are able to produce, but we have to control this plasma. In order to control this plasma, we need to have magnets around this structure. So, we have super magnets installed around these structures. So, we have very powerful super magnets installed around this structure to control the flow of this plasma or the charged particles. So, these are your super magnets. These are the super magnets. Now, we have created plasma, now we are able to control the plasma. So, now fusion can occur inside this plasma. So, let us say hydrogen starts to fuse inside this. So, 4 hydrogen atoms, they are fusing inside to form helium. They are fusing to form helium. And because of fusion, heat will be produced. Because of fusion, heat will be produced in this region. Now, what do we need to do? That this heat that is produced, we need to extract it, and we will utilize this heat to produce steam. So, just like in thermal power plants, how do we produce electricity in thermal power plants? We need to rotate an electric generator. How do we rotate the electric generator? We rotate a turbine. How do we rotate a turbine? We use steam. So, that steam rotates the turbine, and that turbine rotates the electric generator, and that is how electricity is produced. Similarly, in nuclear fusion reactors also, we will be utilizing this heat produced by nuclear fusion. That heat will be extracted, and that will be used to convert water into steam. That steam will rotate turbine, and that will produce electricity. So, how do we extract the heat here? So, just a design implication is there that you have walls. These walls absorb heat. These walls will absorb heat, and then from the walls, using coolant like water, we can extract the heat from the walls, and we can use it to convert water into steam. So, this is how the fusion reactors are designed nowadays. So, this technology is very sophisticated, and not many countries have been able to develop it. In India also, we have one facility in Gujarat, but we are also part of a global consortium in which we are trying to develop a fusion reactor in southern France. What is this project about? So, this project was asked in prelims also one year. So, let us just try to understand this project. So, what is this project? This project is called as ITER. This project is called as ITER, International Thermonuclear Experimental Reactor. International Thermonuclear Experimental Reactor. So, because this fusion technology is so sophisticated that different countries have realized that they will need to collaborate to produce something, a reactor like fusion reactor. So, 35 countries have come together to build a nuclear reactor in southern France. So, in those 35 countries, India is also a member, but all the major countries that you think of is there. So, China is also there, UK is also there, yes, Russia is also there, USA is also there, Korea is also there, obviously South Korea, not North Korea. So, all these major countries, they have collaborated together and they are building a fusion reactor in southern France. So, around 60 to 65% of the work is complete, but the first plasma of this ITER is expected to come around 2025. But despite this global project, there are individual countries also which have built these fusion reactors. So, China has built this fusion reactor, UK has built this fusion reactor, and USA also has these fusion reactors. So, India is also having one facility. So, they are experimenting and researching on that. So, this Chinese reactor or this UK reactor or this US reactor were in news last year. So, we need to know. So, this US reactor was in news very recently. So, let us just try to understand that what is the problem with these type of reactors, that why we have not been able to go to commercial scale, why these are just experimental reactors only. These are experimental reactors only as of now because the fusion. So, we need to give energy, to produce the plasma, we need to give energy to run the super magnets and to maintain the plasma. So, we have to give some input energy to run this reactor. What should be the condition then, that if this has to act as a reactor, then the output should be more than the input. That is, the heat produced by the fusion should be much more than the input that we have given to create plasma, to maintain plasma, to run these magnets. But the output that we see, that is often less, it is just fraction of the input. So, as of now, these are, we cannot call it as a reactor because they are not producing more output than the input that we are giving, and this is the biggest concern with respect to the fusion reactors. So, scientists from 1960s, they have been trying to tweak the design so that they could trigger fusion and the output should be more than the input. But this is a challenging process and it would take more research and development. So, in China, in the Chinese reactor, what is the name of the Chinese reactor? So, these are some factual things. So, Chinese fusion reactor, they call it as yeast, or they famously call it as artificial sun. Artificial sun. And if you look at UK's reactor is called as JET. UK's reactor is called as JET. So, JET, they were able to maintain the fusion. See, why the output is less than the input here in these type of fusion reactors is because we are not able to sustain the fusion for long periods of time. Let us say for 1 hour, for 2 hours, 1 day, 2 days, or for 365 days. Here we are able to fuse. In case of UK, they were able to do fusion, or they were able to sustain the fusion for few seconds only, for few seconds. So, how can we expect that fusion, if it is carrying for only few seconds, it will produce more output than the input given? So, that is the problem in these type of reactors. However, China claimed that they were able to do the fusion for several minutes. They claimed it that around 17 to 20 minutes, for 17 to 20 minutes they were able to sustain the fusion. But obviously all these studies, they need to be corroborated. So we do not have third party studies which is essentially proving their claim. And very recently US has NIF, National Ignition Facility in USA. So USA National Ignition Facility, they recently made a claim. They recently made a claim that the output of the fusion reactor was much more than the input that they had given. However, their claim has not been verified by third parties. So the breakthrough that they are claiming, we will have to wait and watch whether it can be replicated or not, or in future, or whether it can be verified in the future or not. So this fusion reactors, so what we have seen, essentially we are mainly utilizing the concept of tokamak. So what is tokamak? It is a magnetic confinement design. Why magnetic confinement? Because we are trying to control the plasma. See, when we are trying to produce plasma, plasma means superheated state of gases. So if you remember this relation of a gas, if you start increasing temperature, the pressure and volume starts to increase. Or another scenario, if you see that if you increase temperature and if you keep the volume fixed, if the volume is fixed and you are increasing the temperature, what will happen? The pressure will keep on increasing. If you have kept the volume fixed, then pressure will increase. If you are increasing the temperature and if you have fixed the pressure, then the volume will increase. So producing plasma becomes a challenge because there is huge pressure. So because there is huge pressure in this magnetic confinement design, we try to keep the density of hydrogen or the plasma less. So we are trying to find other ways to do fusion. So what are the other ways to do fusion? So one of the famous method of doing fusion is called as cold fusion. Cold fusion. So what is this cold fusion? So we saw that if you have to fuse protons, it is the electromagnetic repulsion which comes as a barrier. So we are not able to fuse these protons. But what if we are able to nullify the charge of the proton? So in order to overcome the electromagnetic repulsion of the proton, we are giving huge amounts of energy or temperature. So what we can do, if we add some charge particles, if we stick some charge particles opposite to the charge of proton, let us say a muon. A muon is a negatively charged, it is negatively charged fermion. Just like an electron, it is a negatively charged fermion. Now when we add this muon to this proton, proton becomes electrically neutral, and because of that this electromagnetic repulsion reduces. And now we can go for fusion. So this fusion is known as cold fusion. Why it is cold? Because we do not need very high temperatures for fusion to happen. So this is also a innovative method, but we need to develop reactors based on this concept. So let us see in future which technology will get more prominence. There is another method to tackle this problem of increasing pressure with increasing temperature, is the laser method that is used. The laser method. So what is done in laser method? That we allow, or we take few protons. And we target many lasers on those protons. We take few protons and we target many lasers on this proton. So what happens? So it leads to generation of very high amount of heat, and because of that high amount of heat, again fusion of hydrogen can occur. So, we allow the explosion of hydrogen, but it is in very small quantity. So, at present we are trying to utilize all these methods to do fusion, but the challenge still remains that the output that we are getting is much less than input. So, why is fusion considered to be future? So, fusion is considered to be future because if you look at all the conventional sources of energy and even nuclear fission also, fusion is said to be much more efficient than even fission. Fission is said to be million times more efficient than burning coal, but fusion is 3 to 4 times more efficient than even nuclear fission also. So, in fusion the biggest advantage that we have is not only the output or efficiency compared to your fission, but the raw material that you need for fusion. In fusion we are needing which type of raw material? We are using just hydrogen as a raw material, but if you look at fission, the raw material that we need is either U-235 or plutonium, and here the input is hydrogen, and hydrogen as an input is in abundance. So, our country, if it does not have sufficient uranium, but every country is having sufficient hydrogen. So, the input or the raw material for fusion reactor is abundantly available. So, all the concerns related to energy security of any country can be easily resolved. And compared to fission, if you look at the output, so if this is the input, the output here you are getting helium, and here you get radioactive waste, and these radioactive waste, management of this is very difficult, and it can cause damage to environment and to human health. That is the biggest concern with respect to nuclear fission. So, people are not ready to give their land to build nuclear fission type of reactors, but for fusion there would be no such concerns. And also fusion reactors is believed to be design wise much more safer than nuclear fission reactions. So, why? So, in nuclear fission, so fission reactions can continue on its own because they follow a chain reaction, but in fusion what do you see? That you need a plasma. If the plasma is cut off, then the fusion reaction cannot continue. So, the fusion reactors are much safer than fission reactors. The incidences like Fukushima or Chernobyl or 3 Mile Island, so which has led to negative perception with respect to nuclear fission energy, we will not encounter such scenarios with respect to fusion reactions. So, that is why it is considered to be the future of energy sector. So, more regarding fusion and fusion, if it comes in news, we'll discuss in further videos. So, thank you for this short video. Thank you all.